We're now going to look at how to draw the graphs of inverse trig functions. So we've got a graph of y equals sine x here, and we're going to try and draw the inverse function, which would be y equals sine minus 1 of x. Now, as I said in the previous video, for us to be able to do this, we have to have a one-to-one function. And so we've achieved that by reducing the domain of the sine x so it's between minus 90 and plus 90. So the domain here, as actually we've said here, the domain is reduced between minus 90 to plus 90 to create a one-to-one function. If we consider the sine graph usually without restricted domain, it would look like this, and it's actually in its unrestricted domain, then it's a many-to-one function. So what we've had to do is reduce the domain so that it's a one-to-one function. So the domain is now minus 90 to plus 90. And to draw the inverse function, all we need to do is we need to reflect in the line y equals x. And to do that, what we can do is we can draw a line from these 2 points of the graph going through 0. So we can draw this line and reflect it in that line so that as well as the graph reflecting, the actual axes will reflect as well. So this 90 here is going to reflect in that line, and it's going to end up here. And the minus 90 is going to reflect, would end up down here if it reflects, and that's going to be minus 90 there. And also the 1 is going to reflect to here, and the minus 1 is going to reflect in this line to here. And so now that we've set up these axes, we can draw the reflection of the original graph in this diagonal line, and it would look like this. And that's our inverse sine function. If we look at the inverse cos function, then we know that what we would be getting the inverse function is arc cos, which is also, so y equals arc cos is one way of saying it, and that's the same, exactly the same as saying cos minus 1 of x. So they mean exactly the same. And so again, we've had to create a one-to-one function by restricting the domain. So the domain here is that x is between 0 and 180, so that we've got a one-to-one function. And again, if I just quickly sketch the graph of cosx, well, cosx looks like this. And so if we've got an unrestricted domain, and so this would be a many-to-one function. So if you, I've gone through this in detail in the previous video, so you could look at that. But it's a many-to-one because there's many, for example, half here, although that's the same as 60 degrees, or cos 60 gives us a half, so does cos of 300. So there's many values of x that would give us the same value of cosx, and so that's why it's a many-to-one function. So now that we've restricted the domain so that it's a one-to-one function, we can again reflect this in the line y equals x. So we're going to reflect in y equals x in order to get the inverse function. So the line y equals x looks like this. And we're going to reflect in that line. So if we do that, it's easiest to reflect the axes first of all. So what we're going to end up with is we're going to end up with positive one's going to reflect there, the negative one's going to reflect there, and then actually the vertical axis starts at 0. We don't have any negative in the range we've restricted this to, 0 to 180. That means that the lowest value vertically is 0, and then the 90 is going to go there, and then actually if I extend that up, there's 180. So that's what the axes now look like, and if we reflect that, we can see that we'd end up with starting off at this point. So this point here reflects to there. This point 90 is actually reflects to there, and so we end up with this shape. So that's our inverse function, where y is equal to cos minus 1 of x. If we look now at the tan function, so again we've had to restrict the domain. So we've created a one-to-one function because, as ever, the inverse will only exist if it's one-to-one. So what we've done is we've restricted the domain here from minus 90 up to plus 90. So the horizontal axis has been restricted. Because again, if we look at the graph of tan, what we've got is asymptotes at 90 degrees, minus 90. And the region that we're restricting it to is this region. But if we continued, then we would get a repeated shape, and it would be a many-to-one function, as we can see. So although this particular angle here, so for example if that was 45, that would be 1, well, we'd get lots of values of x that would give us 1 if we found tan x of it. So like for example, this value here would be 225, and that would also, we did tan of 225, oops, there we go, 225, that would also find 1 as well. So this would be a many-to-one, and there would be no inverse to that one. So we've had to restrict it here. So again, what we're going to do is we're going to reflect in y equals x. So if we do that, we can just take a line like this and reflect in that line. So if we do that, then the axis is the first thing that we actually want to reflect. So the 90 here is going to go up here, and minus 90 is going to end up down here. And then the 2 is going to be here, and minus 2 is going to be here. as well as the axes, the values on the axes that's going to reflect as well, we've got the asymptotes, which were here and here at plus and minus 90. So they're also going to reflect. So they're going to look like this now. So they're going to become horizontal lines at plus 90 and minus 90. And once we've got those on, it becomes a lot easier to draw because they become horizontal asymptotes. So now this line is going to approach the horizontal asymptote at infinity, go through 0, and also approach the horizontal asymptote at minus infinity. So it's going to look like that. So that's the inverse tan function. So that would be y, this would be a graph which is y is equal to tan minus 1 of x.